This is part 3 of our continuing study of solving rational equations. Now, remember in part 2, we started looking at these steps for solving a rational equation. And we noticed that the first thing you had to do was factor the denominators of all of the rational expressions, and then you would identify any value of the variable for which the expression is undefined. Now, that was important because this part here about it being undefined, because you notice that when we did part 2, there were situations where when we got that solution, remember this was a potential possible solution, we saw that that was a restriction, which meant that that restriction, that number here, made this rational expression undefined, which meant that the denominator was 0 in at least one of these fractions. And so that was, remember, called an extraneous solution. All right, same thing here when we did this one where we had this rational equation and we ended up with a quadratic and we solved it. We had two potential solutions. Well, this right here was a restriction because 3 made the denominator 0, which made this undefined. And so that was an extraneous solution. So our actual solution was only this one. That was our solution to the original equation. And so here, when we did this one, both potential solutions here actually worked. So those were the solutions because none of those solutions were restrictions. The only restriction here was x equal -2. Okay, so in part 2, that's where we started looking at the idea of extraneous solutions. And remember, we get extraneous solutions, not always, but we do get extraneous solutions when we multiply both sides of a rational equation by a variable expression. So we can, at some point, introduce an extraneous root. Okay? All right, now notice, even though we had two potential solutions, one was a false solution, this was our only solution, so we had to say just this one. When we did this one, that was our only potential solution. It was a restriction, so we had to say no solution. Okay? All right. Now that's going to take care of that review. Now let's continue talking about this. So once we did part 1, then we multiply both sides by the LCD. We identify the LCD, we multiply both sides by the LCD, and we solve the equation, and then we check the potential solution to see if any were extraneous. Okay? All right, so let's look at number 1. So let's suppose this was number 1. We had x divided by 3x plus 6 minus 3x minus 1 divided by 2x plus 4 equal x plus 2 divided by x plus 2. Okay, so let's say we had that. All right, now I want you to know that the first thing you have to do, remember, step 1, is to factor the denominators. So if you look at this one here, I can factor 3x plus 6. So I can factor 3x plus 6 as 3 times x plus 2, right? Okay. I can factor 2x plus 4. I can write it as 2 times x plus 2. And then x plus 2 here I can't factor. It's prime. So I factor. So step 1 is to factor. Step 2, or still part of step 1, is to find the restrictions. What makes, once you factor, then you ask yourself, what makes this rational expression undefined? Well, here are my factors, 3 and x plus 2. So this will be 0 if x plus 2 is 0. So where is x plus 2 equal to 0? Well, x plus 2 is equal to 0 and x is -2, right? Now let's suppose you factored incorrectly. So you could have messed this thing up. But let's just go back to the 3x plus 6. You could have done that instead. Say 3x plus 6 equals 0. So I get 3x equal -6, and you get x by itself, you divide by 3, and so x is -2. You get the same thing, right? Okay, so it doesn't matter. Over here, what makes 2 times x plus 2 equal to 0? Well, that's 0 when x plus 2 is 0, right? Which you already have. So where's x plus 2 equal to 0? At -2. If you wanted to, you could have used this denominator instead. You could have said, all right, I'm gonna I'm going to say, where's 2x plus 4 equal to 0? Well, 2x plus 4 is equal to 0, and 2x equals negative 4. And if I divide both sides by 2, I get x to be negative 2, which is what we had, right? And the same thing here we already have. So what is the only restriction? The only restriction is that x cannot equal negative 2. That's the only restriction, okay? All right, now I'm going to go ahead and rewrite this right here since I used up a lot of room. And when I do that, I'm going to go ahead and use the factored part. It's important to use the factored part. That's very important. Once you factor, use it instead. So meaning this, I'm going to say x divided by 3 times x plus 2 minus 3x minus 1 divided by 2 times x plus 2 equal x plus 2 divided by x plus 2. Okay? All right. Now, let's find the LCD. So remember, the LCD has to include every factor you see. Okay? So let's start with 3 and 2. What's the smallest number that 3 and 2 go into? The answer is 6. All right. Now, remember, I want this to be a 1. So when I multiply both sides by the LCD, I want this denominator to be a 1. Well, in order for that to be a 1, this x plus 2 has to divide into x plus 2, right? So I need an x plus 2. All right. Now, I already dealt with the 2 because 2 goes into 6. Do I need any other factors of x plus 2? No, because that's only 1 here. How many do you see here? Just 1. And there's 1 here, 1 here. So that's your LCD right here. Okay? Always use the least. Don't use any more than the least because this would be very complicated if you use more than the least. All right. Now, once you find the LCD, you're going to multiply both sides by the LCD. So notice there are 2 fractions here, 2 rational expressions. So you can put that in parentheses, just like this. Again, make sure it's factored. That's going to help you. The denominator's factored. Leave it alone. Okay, so now I'm going to multiply both sides by the LCD. So it'll be 6 times x plus 2. 6 times x plus 2. Okay? All right, now you're going to distribute. Okay, now watch what I do. So I'm going to say, let's do this first. This times this. So 6 times x plus 2 times x divided by 3 times x plus 2, right? Okay. Then I'm going to say minus 6 times x plus 2 times, in parentheses, put that in parentheses, 3x minus 1 divided by 2 times x plus 2 equal, and at this point I'm just going to go ahead and reduce this. Okay, but you got to be careful because look, you got to put this in parentheses because 6 is being multiplied by every term x plus 2. Okay, so that's important. See what I did here? You got to put that because you're going to be distributing that 6. So it's not just x plus 2 times 6. I won't say x plus 12. Okay, all of this has to be multiplied by 6. So that parentheses is important. Okay, now at this point we'll go ahead and reduce. 3 into 3 is 1. That's what we wanted. Remember, we wanted this to all be 1s. 3 into 6 is 2. X plus 2 into x plus 2 is 1. X plus 2 into x plus 2 is 1. 2 into 2 is 1. 2 into 6 is 3. X plus 2 into x plus 2 is 1. X plus 2 into x plus 2 is 1. And so now look at what we have. We have 2 times 1 times x is 2x minus 3 times 1 times 3x minus 1. So I'm going to go ahead and actually write it out like this so I don't mess up. Okay, write it out. Don't mess up. Just don't do this in your head. Equal, and that's going to be 6x plus 12. 6x plus 12. Now let's go ahead and distribute here. I get 2x minus 9x plus 3 equals 6x plus 12. So notice that, and we're not done, but notice that at some point, if you're not careful, you're going to mess up with a sign or a term or something like that. So be careful. Now notice this is what kind of equation? This is a linear equation. So I'm just going to combine like terms. That'll be a negative 7x plus 3 equals 6x plus 12. All right, I'm going to bring all the variables one side, so I'm going to subtract 6x from both sides. And so I get negative 7x and a negative 6x is a negative 13x plus 3 equal 12. Subtracting 3, I get negative 13x equal 12 minus 3 is 9. Divide both sides by negative 13. I get x to be a negative 9/13. Now, is that a restriction? Nope. So as long as I did all the work correct, this is my solution. So that's your solution. That's the solution. So in other words, is this an extraneous solution? No, it's not extraneous because it's not going to make my denominator 0, right? The only number that makes my denominator 0 is x if x is negative 2. So that's your solution. All right, so that's number 1. Number 2. So notice number 1, this is where we had to actually factor first. That's important. You had to factor first, and then when you factor, when you write the next step, make sure it's factored. Okay, make sure it's factored because that helped. The reason it helped was this little part here when you reduced. See, if you had left it like this, you would have had a hard time reducing. It would have been extremely difficult for you. So the whole reason why you want to leave it factored is so you can reduce a lot easier. Okay? We're going to talk about again. We're going to talk about that in the next problem as well. So number 2. Number 2, suppose you had 3m divided by 2m minus 5 minus 7 divided by 3m plus 1 equal 3 halves. Okay? All right, step 1, remember, is to factor the denominators. Factor the denominators and then identify any values of x for which the expression is undefined. Well, if you notice 2m minus 5, I cannot factor. That's prime. 3m plus 1 is prime, and then 2 is just a monomial. So now I can find the I can find my restriction. Let's find the restrictions first, and then we'll do the LCD. So ask yourself, where is 2m minus 5 equal to 0? Well, that's a linear equation, so I can go ahead and solve this linear equation, but add 5 to both sides. And so I get 2m equal 5 divided by 2. I get m to be 5 halves. Okay, so that's one of my restrictions. M cannot equal 5 halves. There's another one, though, right here, because that's a different factor. So I got to do that as well. So 3m plus 1 equals 0. Where is that equal to 0? Well, I'm going to subtract 1 from both sides. So I get 3m equal negative 1. Divide both sides by 3. I get m to be negative 1/3. So in this case, notice how many restrictions did you have? You had 2. Okay? So negative 1/3. So when I do all this work, and let's say I get a potential solution that's one of these, I cannot use it. That's a extraneous solution. Okay? All right. So now the LCD. Let's talk about the LCD. All right. So the LCD, remember, has to include every factor you see. That's the only way you can get, when you reduce, you can get a 1 down here. So I need a 2m minus 5. I need a 3m plus 1. And I need 2. So I'm going to go ahead and put the monomial in the front. Okay? All right. So notice 2m minus 5 is listed. 3m plus 1 is listed. And 2 is listed. Okay? So there's your LCD. Once you find the LCD, you'll multiply both sides by. So let's put that in parentheses right here since that's 2 fractions. Just like this. Okay? Put that in parentheses. And then we're going to multiply both sides by the LCD. So you can say 2 times 2m minus 5 times 3m plus 1. Okay? Over here, same thing. 2 times 2m minus 5 times 3m plus 1. Okay, now notice that over here you have 3 factors that you can distribute. 1, 2, 3. When I did number 1, notice there were 2 factors, 6 and x plus 2, that I distributed. Okay, so just be careful. It can get pretty messy. Can get pretty messy. Okay, so this times this. So we're going to say 2 times 2m minus 5 times 3m plus 1 times the first fraction minus, and I'm running out of room, so I'm going to go ahead and actually put it down here. So 2 times 2m minus 5 times 3m plus 1 times the first fraction, that's right here, 3m over 2m minus 5 minus, and then the same thing, 2 times 2m minus 5 times 3m plus 1 times 7 divided by 3m plus 1. Notice how much work this becomes, so you got to be very careful. Equal, and I'm going to go ahead and at this point just reduce these. Okay, the 2's divide out, so you get 3 times 2m minus 5 times 3m plus 1. Okay, all right, now listen carefully to what's going to happen. So this is going to be pretty messy. Okay, so we need to reduce what we can. Okay, we need to reduce what we can. So let's see. Let me see what we can do. Okay, so right here I can reduce these, right? The 2m minus 5s. Y'all agree? Over here, what can I reduce? Remember, the whole point of multiplying by the LCD is to make these denominators factors of 1s. So over here, the 3m plus 1s divide out, and that's about all I can do. Now look how messy this is going to be. Now in your test, you're not going to have one this messy, because it is pretty involved, right? See how involved this is? Pretty involved. But notice that at many places, if you're not careful, you can easily make a mistake. All right, so what I would do here, see how you have 2 times 3m plus 1 times 3m? Here's what I would do first. Okay, so I'm going to go ahead and rewrite this. So look at what you have. You have 2 times 1 is 2 times 3m plus 1 times 3m, right? Okay, minus, and then here you have 2 times 2m minus 5 times 1 times 7. Y'all agree so far? This is what it looks like? What you see? This is just what you see. Equal, and then this is just 3 times 2m minus 5 times 3m plus 1. Okay, now look how messy this is going to be, so listen carefully. Okay, do you see that you're multiplying 3 factors together? 2 times 3m plus 1 times 3m. So what you can do, remember, these are all multiplication, right? So let's multiply from left to right. So let's do this first. So how do I multiply a monomial times a binomial? I use the distributive property. So this becomes 6m plus 2. And that's being multiplied by 3m. Y'all agree? Okay, so this times this. Now don't say 2 times 3m. You know that you can't do that. You go from left to right. So you're multiplying this, whatever that is, you're multiplying by that. Okay? Minus, and then let's kind of do the same thing here. Let's put that in parentheses. Now, just go ahead and leave this as minus for right now. So just distribute the 2. So that's 4m minus 10. You agree with that? And that's being multiplied by 7. Just write what you see. Write what you see. Equal. Same thing here. Just distribute this. You get 6m minus 15 times 3m plus 1. Okay? Now here's what I would do here. You see how you have a binomial times a monomial? Let's go ahead and put that in front. So 3m times 6m plus 2 minus, and you see how you have a binomial times a monomial? Put that in front. Because remember, multiplication is commutative. The order in which you multiply doesn't matter, so put that in front. 4m minus 10, and then I'm going to leave this as 2 binomials. Okay, it's getting pretty messy, isn't it? All right, now let's get rid of these parentheses. So we distribute. 3m times 6m is 18m squared. 3m times 2 is 6m. Okay, so be very careful. So if you messed up anywhere around here, then all of this will have been for nothing. All right, so be very careful. You could easily mess up, okay? All right, and then distribute the negative 7. So you get minus 28m, and a negative 7 times a negative 10 is a positive 70, equal. Now, how do I multiply this out? You have a binomial times a binomial, so let's use the FOIL method. So 6m times 3m is 18m squared, the outer. 6m times 1 is 6m, inner. A negative 15 times 3m is a negative 45m. And the last, a negative 15 times 1 is a negative 15. Okay? Combining like terms on each side, I get 18m squared. Now 6m and a negative 28m is a negative 22m plus 70 equal 18m squared. 6m and a negative 45m is a negative 39m minus 15. Now, look, you may think, hey, I have a quadratic equation I ended up with. Well, actually, it's not, because what happens is that the 18m squareds divide out. I'm sorry, not divide out, but they cancel out, right? And you get this. You get negative 22m plus 70 equals negative 39m minus 15. So you really end up with a linear equation. That's what you really ended up with. Now let's go ahead and finish this. So we need to solve this linear equation. So notice I need another sheet of paper. I know it's a lot of work, isn't it? It's a lot of work. All right. So I'm going to go ahead and rewrite this over. Negative 22m plus 70 equals negative 39m minus 15. So let's go ahead and add 39m to both sides. So bring variables one side, constants to the other. All right, so notice 39m plus 39m. When I combine like terms, this becomes 17m plus 70 equal, this is 0, negative 15. Subtract 70 from both sides. I get 17m equals a negative 85, right? And then when I divide both sides by 17, I get m to be, and use your calculator, you get m to be a negative 5. Okay, so m to be a negative 5. All right, there's your potential solution. Is it a solution, though? How can you tell if that's a solution? Now, let's just assume that you did all the work correct, okay? All this is correct. How can you tell if this potential solution is really your solution? You go back to your restrictions. Was negative 5 a restriction? No, it was not. Negative 5 was not a restriction, so if I did all this correct, this works. Okay? So, is negative 5 an extraneous root? No, it's not. Extraneous solution, extraneous root, root solution mean the same thing. No, so that's the solution. So your solution is x equal negative 5. Okay? Not x, I'm so sorry. M. M equals negative 5. Gotta use the variable involved. M. You want to check it? You want to make sure that because you could have made a mistake, right, all along the way. And you could have said this was negative 4. Could have made a mistake and ended up with negative 4. Well, let's see if this works. All right, so always, if you have time, check. If you have time, check. Go back to the original, though. Here's the original, so I'm going to go ahead and rewrite it. So let's check it. All right, so let's check this. M equal negative 5. Okay, so here was my original. 3m divided by 2m minus 5 minus 7 divided by 3m plus 1. And we see that's equal to 3 halves, right? Okay, so negative 5. The numerator is 3 times negative 5, correct? The denominator is 2 times negative 5 minus 5. Over here, I get 7 divided by 3 times negative 5 plus 1. Y'all agree? And at some point, I want to see if that's going to equal 3 halves. Well, let's kind of fool with this one. So that's negative 15 2 times negative 5 is a negative 10. A negative 10 and a negative 5 is a negative 15. So you'll see that's a 1 right here, right? Over here, minus 7 divided by 3 times negative 5 is a negative 15. Negative 15 plus 1 is a negative 14. Now look at what I have. I have 1 minus a negative 7/14. Y'all agree? Reduce this right here. That becomes 1 minus a negative 1/2. Well, 1 minus a negative 1/2 means 1 plus 1/2. And is that the same thing as 3/2? Yeah. 1 plus 1/2 is 1.5. 3/2 is 1.5. All right, so m equal negative 5 is the solution. Notice, guys, how messy this can be. You see all this? It can be messy, right? So be careful. Be careful. And again, you're not going to have one that involved in the test. Look how long it took. All right, it took me that long. Of course, I was discussing a lot of stuff. It'll take you a little bit longer as well. Okay? All right, let's go to number 3. Number 3. Okay, number 3, let's suppose you had x divided by x minus 1 minus 2 divided by x plus 1 equal 4x squared divided by x squared minus 1. Okay? All right, so the first thing we got to do, remember, is to factor the denominators. Can I factor x minus 1? Nope. Can I factor x plus 1? Nope. Can I factor x squared minus 1? Yes. That's a difference of 2 squares. So I get x minus 1, x plus 1. Okay, so let's find the restrictions. All right, what makes this denominator 0 when x is what? 1. When x is 1, so x is not equal 1. What makes this denominator 0 when x is what? Negative 1. Now let's go over here. What makes this denominator 0? Well, how many factors do you see? You see 2, so you got to check each one. I already did this one because that's this one, isn't it? So I already have one listed. What makes this one 0? Well, I already did it. That's this one, so that's negative 1. So how many restrictions does this equation have? 2. 2 restrictions. Okay? All right, now I'm going to go ahead and rewrite this using the factored part. So remember a while ago we said once you factor, use the factored part. Okay, so I get x divided by x minus 1 minus 2 divided by x plus 1 equal 4x squared divided by x minus 1 times x plus 1. Okay, you're going to see why in a little while. Now the LCD. Your LCD has to include every factor you see, all right? Because if I want this to be a 1, then I've got to multiply by that same factor, x minus 1. Here, I need an x plus 1. X minus 1 I already have, x plus 1 I already have. Okay, so there's your LCD. So your LCD has 2 factors. I'm going to now put this in parentheses because I've got to multiply both sides by the LCD now. X minus 1, x plus 1. X minus 1, x plus 1. What you do to the left side, you do to the right side. See that? Now, what's the next step? So really, this was the more difficult part because the rest you had practice with many times last year and this year. So let's go ahead and distribute. So x minus 1 times x plus 1 times the first fraction, first rational expression, minus, and then the LCD times the second. X minus 1, x plus 1 times 2 divided by x plus 1 equal, and at this point I'm going to go ahead and reduce these. So that's x minus 1 is 1, x plus 1 divided to x plus 1 is 1, and so notice all you're left with is 4x squared. That's all you're left with because 4x squared times 1 is 4x squared. And now at this point I'm going to reduce what I can here, so x minus 1 divided to x minus 1 is 1. Remember the whole point of multiplying by the LCD is to make this a 1, right? Same thing here. Now I'm going to go ahead and rewrite what I have. So this is 1 times x plus 1 times x. So I'm going to put the monomial factor first. So do y'all agree that that right here can be written as x times x plus 1? This times this times this is this. Okay? Minus, same thing here. Put the monomial factor first. So x minus 1 times 2 is 2 times x minus 1. And then equal 4x squared. All right, what do you think the next step is? Distribute, right? So x times x and x times 1. So that's x squared plus x. And then here distribute the negative 2 minus 2x plus 2, right? Negative 2 times a negative 1 is a positive 2 equal 4x squared. Combine like terms. Let's go ahead and do that on this side. I get x squared, x minus 2x and negative x, and then plus 2 equal 4x squared. Okay, now look at what we have. All right, I went from a rational equation to a quadratic equation. Okay, now let's go ahead and put this in standard form. Now you see how the coefficient of x squared on both sides? It's always easier to factor if the coefficient of x squared is positive. So let's bring this to the other side. Let's bring all these terms to the other side. Okay? All right, because if you bring the 4x squared over, you're going to get a negative 4x squared plus x squared is a negative 3x squared. And most students have trouble factoring when the coefficient of x squared is negative. So let's just bring everything to the other side. So I'm going to subtract x squared from both sides. So do it in steps. So this is 0, so I get negative x plus 12 equal 4x squared minus x squared is 3x squared. And then I'm going to add x to both sides. So this is 0, so I get 12 equals 3x squared plus x. I'm going to subtract 12 from both sides, so I get 0 equal 3x squared plus x minus 12. Okay? Now I'm going to go ahead and put this one in front. So remember I can transpose the sides. So 3x squared plus x minus 12 equals 0. Okay, now I'm going to factor. And when I do that, I'm going to get 3x, x. I'm going to need, let's see, 2, 2, 2. Let's see which one's going to work. And so when I try factoring this, you notice how I tried 2 and 6, 4 and 3, and nothing seemed to work, right? Well, notice, I want you to notice something. What do you see here? Plus 2, what did I write? 12. Where in the world did they get a 12 from? What should that have been? A 2. So yeah, so sometimes when you do things quickly, you tend to mess up. So be very careful. That should be a 2. That should be a 2 right here. So subtracting 2 from both sides. That should be a 2. That should be a 2, right? So yeah, sorry about that. Okay, so that's 3x squared plus x minus 2. So let's see what's going to work now. So I need this to be a 2, this to be a 1, right? And the last sign's negative, so these have to be different. I need the middle sign to be positive, so that means this is plus, this is minus. So let's check. So again, be careful. I have no idea where I went from 2 to 12. All right, so the outer is 3x, the inner is a negative 2x. I do get x, and so this works. All right, so now we're going to set each factor equal to 0. So I get 3x minus 2 equals 0, x plus 1 equals 0, so x equals negative 1 here. Over here, 3x equals 2, which means x is 2/3. All right, now remember those are your potential solutions. Potential. They're solutions to this quadratic. They're definitely solutions to quadratic. That is true. But are they solutions to the original? Yes or no? Well, one is and the other one isn't, right? Because look at your restriction. What was the restriction? 1 and negative 1. What do you notice here? That's negative 1. Negative 1 makes this denominator 0. It also makes this denominator 0. So remember, you cannot divide by 0. So this right here is your extraneous root or solution. So your actual solution, so your answer, you're going to say x equal blank. So what goes in the blank? 2/3. Okay? All right. So that's number 3. Let's look at one more. So again, notice how long this can become, okay? All right. And then number 4, let's suppose we had this for number 4. All right, number 4, we had x minus 1 divided by x minus 2 plus x plus 4 divided by 2x plus 1 equal 1 divided by 2x squared minus 3x minus 2. Okay? All right, so I have this rational equation. It looks complicated, but after all these problems, you should be getting a little bit better with it. What's the first thing you're going to do? First thing you're going to do is factor, right? You're going to factor the denominators, all right? Can I factor this denominator? No. Can I factor this denominator? No. Can I factor this denominator? Probably. Let's do it. Now here's kind of the hint here. So you see how this is a quadratic expression. These are linear. Chances are when you factor this, it'll be these factors here. Not always, but most of the time, that the way these things are set up, you're going to notice that, hey, these factors are the same as these. All right, 2x, x, 2, 1, and notice that last sign's negatives. That means that one's negative, one's positive, and this is negative, this is positive, okay? And so if you check, you will see you get these three terms. Again, notice 2x plus 1, 2x plus 1. X minus 2, x minus 2. Kind of the same thing over here. When you went back to the previous one, didn't it kind of look like that too? When I factor this, when these factors here, most of the time, that's the way these problems are set up. Because otherwise, this would be so complicated, so they can't make this part too difficult for you. Because then this would be almost impossible for you to deal with. All right, so now let's find the restriction. Now guys, all you got to do, you see how these two factors are already listed? Just look at these. What makes this 0? Then you can look at and tell me. Well, 2 makes this 0, right? X equal 2. So your restriction is that x cannot equal 2. Now over here, some of you may have a little bit of trouble. So what I would do is I would write this, 2x plus 1, set equals 0, and solve it. So I'm going to subtract 1 from both sides. So I get 2x equal negative 1. Divide by 2, so you found x to be negative 1/2. So those are your restrictions. X cannot equal 2, and x cannot equal negative 1/2. All right, now once you find your restriction, what's the next thing you do? Step 2, identify the LCD. Step 2, the LCD. So what's the LCD? So that's an easy one as well. So the LCD has to include every factor you see. I have an x minus 2, I have to use it. That's the only way I can reduce this with a common factor, is if this is in the common factor. So it must be listed here. Okay. Then the other factor I see is 2x plus 1, so I have to use it. Right? Then the next one I see is 2x plus 1, I already have it. And then x minus 2, I already have it. So there's your LCD. It's just these two factors. What do you do with that LCD? Well, that's step 3. You multiply both sides by the LCD. All right, so let's go ahead and kind of rewrite this down here. But remember, when you rewrite it, make sure don't use this. You got to use your factored part. Okay, so the factored part helps you because if you didn't factor, if you left it like this, some of you would have been hard pressed to see that this and this were the same thing. Okay, so leave it in factored form. All right, so on a rewrite, I'm going to say x minus 1 divided by x minus 2 plus x plus 4 divided by 2x plus 1 equal 1 divided by, in parentheses, the factored part, 2x plus 1 times x minus 2. Okay? And I'm going to multiply both sides by the LCD. X minus 2, 2x plus 1. X minus 2, times 2x plus 1. Okay? Now, once you do that, remember the next step is to distribute. So I get the LCD, x minus 2 times 2x plus 1 times the first fraction. Put that in parentheses, like this, the numerator, plus the LCD times this, x minus 2 times 2x plus 1 times, in parentheses, x plus 4 divided by 2x plus 1 equal, and then since I'm running out of room, I'm going to go ahead and reduce these. So notice that 2x plus 1 reduces with 2x plus 1. X minus 2 reduces with x minus 2. And notice what you have. 1 times 1 times 1 is 1. Okay? Now let's go ahead and reduce this. So I have x minus 2 reduces to x minus 2. 2x plus 1 reduces into 2x plus 1. Okay? Now notice what you have though. I have 1 times 2x plus 1 times x minus 1 is 2x plus 1 times x minus 1. Okay? That is this. Plus, okay, over here I have x minus 2 times 1 times x plus 4. Just like this. Equal 1. All right, so that's where I'm at. Notice, guys, the next step, you see you still have parentheses, right? So how can I get rid of the parentheses from this product? I'm multiplying two binomials, so I FOIL. Same thing here. Multiplying two binomials, I FOIL. Okay, so let's do that. 2x times x is 2x squared. The outer is a negative 2x. 2x times a negative 1 is a negative 2x. The inner is a positive x. And the last is a positive 1 times negative 1 is a negative 1. Plus, over here, x times x is x squared. The outer is 4x. The inner is a negative 2x. And the last, a negative 2 times 4, is a negative 8, equal 1. All right, combining like terms now. 2x squared and x squared is 3x squared. A negative 2x and a positive x is a negative x. A negative x and 4x is a positive 3x. Okay? 3x and a negative 2x is a positive x. That's plus x. Let's do it again. A negative 2 plus 1 is a negative. Use your calculator if you need to. If you're just adding the coefficients, look, you're saying this. Negative 2 plus 1 plus 4 minus 2, right? Equal 1. So you just get 1x right here. Okay, a negative 1 and a negative 8 is a negative 9 equal 1. All right, now remember, you see this is a quadratic equation, right? But you need 0 on this side, so let's subtract 1 from both sides. And so I get 3x squared plus x minus 10 equals 0. And I'm going to factor this quadratic equation. And when I do that, hopefully I didn't make a mistake anywhere. Let's see, hopefully I didn't. So when I do that, I'm going to get 5 and 2 here. And then this is negative, and I need the middle sign to be positive. So this has to be positive, this has to be negative. And let's check it. The outer is 6x, the inner is a negative 5x. I get x, and then negative 5 times 2 is a negative 10. So it works. So now I'm going to set each factor equal to 0. So 3x minus 5 equals 0. X plus 2 equals 0. And then I solve each equation. So 3x equals 5. So x is 5/3. X here is negative 2. So those are my potential solutions. So those are solutions to the quadratic equation. But the question is, are they solutions to the rational equation? Well, look at your restrictions. My restrictions are 2 and negative 1/2. Are any of these your restrictions? No. This is 5/3 and negative 2. So your potential solutions are actually your solutions. So my solutions are both of those. X equals 5/3 and x equals negative 2. Okay? All right, so that was part 3 of solving rational equations. So there are some more videos in Canvas on solving rational equations, these different problems from these. So take a look at those if you still have some questions. So it is a good idea to go back and because this solving rational equations is not easy. Up until this point, it's probably the more difficult type of equation you've had to solve. Okay, so go back. What I would do is I'd go back and write the equations and then see if I can do the rest on my own. If you get stuck, go back to the video, get to the point where you get stuck, see what the next part is, and then stop the video and then try and do the rest on your own. That's the way I would do this. It is a difficult concept, but on the final, they do have one problem. They usually have one problem in the final where you have to solve a rational equation. Okay? So you can't just blow it off because that's like 10 points possibly. That's 10 points. You don't want to blow it off. On your test, you are going to have one rational equation, it won't be involved as the previous one. Remember there was one that was so involved? It won't be that bad. You'll be able to deal with it. So don't get too worried about this. But the way to study this is to go back, write these problems down, the original, see how far you can go. If you get stuck, go back to the video to that point, let it run for the next step, pause the video, and see how far you can go. Okay? All right, so that's what I would do. All right, good luck with this. It's not that bad, but it's not the easiest thing you've had either. So this is not easy for students. But if you study it, you can do it.